on light, and we're going to be talking about lenses this time. So the last video was about mirrors, and it was about reflecting light. Light would come in and bounce off, and remember, the key to every single one of those diagrams I had up here was the angle of incidence equaled the angle of reflection, and wherever those things came together, those light rays, even in the one that went out, if you put them back, that's where the actual image was going to be. Two of them were behind the mirror, virtual images. One of them in front of the mirror was a real image. So now we're going to play with a couple things. I don't have any prisms here. I blew it. I should have brought one home, but I didn't. But you might have a prism at home. In fact, some of you might have prisms that are, you hang from the window and it creates little rainbows all over the place. So lenses refract light. In other words, the difference between reflection and refraction is reflection bounces off, refraction goes through. So if I was a prism, a typical triangular prism, the light would come through. When it hit this, it would be like it would slow down at the bottom and speed up at the top because the bottom enters first, and it would get bent. When it comes out, the top leaves the lens first, the bottom's still dragging, so it'll get bent again. So when you see light, you see it bend. Now this is my eye, and just like the mirror, my eye can't bend light, so I see the image up here. So the actual image to this thing would be up behind the thing. It's just like a flat mirror. It's just the reverse because you're on the other side because the light's going through it. Now I wish I had my prism because I could show you how Mr. Snowman here, if I put him in there, you would see him up here and behind where you're looking at him from, which is really unfortunate that I don't have one. But you're just going to have to trust me on this. If you have a little triangular prism at home, you can try it. But here's another thing you can do. You can take water in a jar, put a pencil in it, and the pencil will offset. That's refraction. Your eye is trying to line those up, and it can't because the wave got bent from here over to there. And so you see the pencil like cut in half. This half sticking out of the water, this half sticking in. That's due to refraction. So remember that when you're doing your project. Another one that we can have is a convex lens. This is a magnifying glass. This is a big magnifying glass. So this is going to be really cool. And the light will come in, and just like the prism, it'll be like a prism on top. So it'll get bent and get bent. Bent when it goes in, bent when it comes out. Remember, the speed of the wave is determined by the medium. So when it enters this lens or the prism or this lens, it slows down. And when it comes out, it flies back faster and it ends up getting bent. So this one comes in, it gets bent up, and then it gets bent up again. And this bending is the refraction. I like to call it the mud puddle principle. Because if I took a front-wheel drive car and drove through a triangular mud puddle, this is what would happen. I would be driving, and my bottom wheel would get stuck, and my top wheel would drive. Notice how it bent. And then I come out of the puddle, and this one would hit dry land and catch friction, and this one would still be stuck, and it would get bent again. Drive through a triangular mud puddle with a front-wheel drive car, and you'll get refracted. It happens to you in the snow. When you're driving and you get caught off the side of the road and the one wheel gets caught in the snow, the other one's still moving fast, boom, and you're right off the side into the ditch. That's refraction. So this happens driving up, driving down, image going to be on the same side as the viewer. So this is going to be kind of a cool one. I'm going to put Mr. Snowman in this lens. And you can see as I come this way, he's about the same size, but notice you don't see the snowman. He's behind the lens. You see the image of the snowman. Now I can make him great big, or I can make him really small. Okay? He'll never get smaller than his actual size. I could make his nose and face really big. Okay, so there's his nose and his face, and we can come right back. That image you're looking at is real. The lines of light are reflecting off that, hitting the snowman and then coming back at you right through the camera. And you get to see that image grow and shrink. Magnifying glass. Okay, now this is a real image because you are on the side of the image. So the actual lines of light are coming off him and going into the camera. Just like this. Now the reason it gets larger, the farther I get away from that focus, you can see he's very small. And then he gets very, very large just by moving this in and out. One of the things you can do with a magnifying glass is start a fire. And that's because you can put the focus right there and you can focus that thing right down. Again, this is a real image. We call this a convex lens, just like the convex mirror. This last one's going to be pretty cool, looking at it through the video. This is a concave lens. So this is like this thing with another hourglass on top of it. You can see if I cut it down and I was driving into this, I would get shot up and then shot up again, and the bottom half would go the other way. So the image that I see, these two rays of light, remember our brain can't bend them, are going to be right back here. So the image is going to be tiny and behind. Okay, so you can see Mr. Guy right here. It's like he's got a little tiny head on top of the snowman. There's his head. There's his head now. And the farther I bring him back, the more you're going to see. And in fact, right there, you can see the entire snowman. Now, that entire snowman for you isn't back where he is. Remember, it's hitting and going this way. So you are looking at a virtual image. It's behind the lens. Just like when I was looking here, the image in the mirror will be behind the mirror. In this prism, it would be behind the prism, on the other side from our eye. So this is created by your brain. It's a virtual image. It's not real. It's not created by real light.